Okay, in this last video, I'd like to talk about using the calculator to do the solutions to these kinds of questions. So, what I'm going to do is I'm going to go into the main screen of the calculator. Now, I've got some stuff left over from last time. What I'm going to do is I'm going to just write the equation in. You can see I've brought up my keyboard here, so I'll just go into trig to get access to the tan function. And I need to put in root 3. Make sure that I'm outside the root sign before I put tan of 3x. I can close the brackets there, and then minus 1 equals 0. To solve an equation like this, all I have to do is highlight it, go to interactive, equation inequality, and choose solve. And it's going to solve it for me, and it gives me all this rubbish. Okay, now first off we can see there's a problem because it's in decimal. You might recognize this here as being pi over 3, but we can see all this here, constant 1, and it's just a mess. Okay, so we don't really want to have something like that. This constant 1 here, that just refers to like a letter n or a letter k or something like that. You know, it's a constant being used. So what we've actually got here is a general solution, and it doesn't really do us much good. So I'll just change it into standard, come back here. Looks much nicer, but it's still pretty useless as it is. Okay, we will get into general solutions a little bit later in the topic. What I'm going to do instead is I'm going to go back just here next to the 0, and I'm going to include the domain restrictions. So to do a domain restriction, I go into Math 3. I choose this sign right here. So this means given. Okay, and now I can specify the domain. So I'm going to say 0 is less than or equal to, just over here as well, x, and less than or equal to the other boundary, which was pi on 2. There we are. And if I hit execute this time, I get exactly the two solutions that I had from the previous problem. So x equals pi on 18 and x equals 7 pi on 18. So this is a much more efficient way of dealing with these kinds of problems. You need to pay attention when you're doing a question like this to whether it is dealing with degrees or radians, and change your calculator accordingly down here. But I'd say that for the purposes of math methods, you're going to be dealing with radians most of the time. And honestly, when they have questions in the textbook that step away from that, I don't know why they bother to do that. But anyway, they just like to mix things up a bit. What I'll also say is that whenever you encounter a question like this and it's got some kind of decimal value, like not a nice decimal value, so say you had cos theta equals 0.7, then that's an indication that you should straight away go for using your calculator and figure it out that way. Anyway, that's all for today, so we'll see you next time.